Okay, so hello everyone and welcome. It's probably been a long day of talks for everyone, so we appreciate you making it to one of the final slots. So, introductions. My name is Victor van der Helm. I've got about 8 years in offensive security, and lately I've been working in red teaming. I enjoy malware development and automation, and in my free time I'll be snowboarding or making pizza.
Cool, yep. Hi, I'm Matthew. So I've been in the industry for about 6 years now. My kind of technical niche is just stupid things that work. It's not really a proper niche, but it's what I enjoy. And then in my spare time, I try and keep this guy alive despite his best efforts.
Great, so a few disclaimers. This is an introductory guide, so we're not going to be dropping any like 0 days or anything like that. We're not macOS experts by any means, we're just sharing our knowledge and experience, and there's nothing here related to our employers, and obviously please don't use this for illegal purposes. So why are we doing this talk? So really the whole point of this talk is to kind of share knowledge to the general security crowd about macOS specifically. Generally macOS has been becoming more popular lately. A lot of modern companies are just using macOS today from the start. macOS is also quite unusual as a system. It's not, there's not a whole bunch of information out there about the security considerations around it. So generally we're just trying to bring macOS security knowledge to the people, whether you're an experienced security professional working with Windows and Linux, or perhaps a student trying to get into the industry. So we're hoping that this talk will give you like a solid foundational kind of knowledge on macOS. So the talk will be kind of structured like so there'll be a bit of a foundational basics piece, and then a more practical bit with Matt, and then finally some sort of defense and OPSEC considerations. So for anyone that doesn't know, a really quick intro to what red teaming is. It's basically a realistic kind of attack simulation where we're trying to go from point A to point B, so really to the crown jewels, and the whole scope is an organization in its entirety, and the whole goal is to do it undetected. So a bit of context before we start. If you consider a macOS organization, typically it'll be something like a zero trust architecture, especially with these modern companies. So what does that mean? It means typically you'll have a set of endpoints, for example Mac devices, something like an IDP to handle your authorization and authentication, and then a whole bunch of cloud services that you will be authenticating to, which will hold your data and your operational technology, etc. So yeah, everyone probably is familiar with IDPs, but that will be things like your Entra ID, Google Okta, those kind of things, and they kind of govern the security policies of your organization. So macOS. So if you were to approach a macOS system for the first time and you never got your hands on one or you've never seen one, it would kind of look like a Linux-y kind of thing. It's actually got a lot of the same binaries as a typical Linux distribution, and the CLI kind of use of it will feel very familiar. A lot of the switches might be different though, for example for SED, etc. The kernel is XNU, and this is quite an interesting kernel as it has two microkernels as part of it, one of which is BSD and the other is Match, Apple's proprietary kernel. In the past, MacBooks have ran on Intel, and then more recently they've shifted to only ARM, so you will have all your modern MacBooks today will be ARM based. An interesting thing to note is that the applications are kind of siloed in macOS systems, and furthermore there's like a sort of granular permission layer applied to the applications in binaries. And by that I don't mean the user execution context, as whether it's a root user or a standard user executing the binary, but rather the application itself will have a set of permissions that dictate what it can do on the system. I'll get into that more later. So if we were to kind of think about the main security pillars of a macOS system, you would have SIP, Gatekeeper, and TCC, and these all together kind of are basically the core security features on macOS. So SIP stands for System Integrity Protection, and what it is essentially is a security layer which protects core operating system functionality and libraries and the kernel from kind of tampering. Generally, the idea behind it is not allowing the users or the admins of these systems to kind of intentionally or unintentionally tamper with the system in such a way that it's disrupted and that you lose access to the functionality. What this means as well is that the root user on a macOS system is no longer the most powerful user on the system. So if you're coming from the Linux world, you would think that the root user could do whatever they want, such as loading in kernel extensions, etc., and just taking down the system and deleting all the files. That's kind of been nerfed in this case on macOS. Another kind of really important security feature on macOS is Gatekeeper. So this will be your kind of built-in application control layer. So it does quite a few things, and generally it will there'll be a number of checks that are enforced when an application or a binary is run on a macOS system. And one of the ones to note will be the quarantine attribute. So if it's kind of like a flag that's appended to an application or a binary when it's downloaded from the internet, similar to your Windows mark of the web. So that will kind of be used to determine whether it's malicious or not, or it should be allowed to execute in your environment. Another really kind of crucial check that Gatekeeper does is a signature check. So applications will have a signature often in macOS, and or might be notarized. And generally, the existence of a signature will kind of indicate whether it's been vetted in some way by Apple. And Apple kind of strongly encourage, if not require, a signature, especially when you consider things like distribution on like their app stores, etc. Part of the signature is entitlements, which, if you remember from couple slides ago, this sort of granular application permission layer. So embedded within a signature for your application and binaries, you will have something that dictates what your application can do on the system. So this could be something that indicates that your application can access the microphone or the webcam on your MacBook, or perhaps something else that will be an exception for how it could work with the operating system. For example, loading in unsigned libraries into your application. So if you wanted to visualize the signature, you could use the code sign utility in macOS. So in the top left, you can see the signature for the Java binary, which is basically indicating that it's been signed by Apple. So this is a trusted binary. And then on the bottom right, you can see the entitlements associated with the Java binary, kind of indicating what it can do on the system. So if you wanted to, we thought it would be quite useful to visualize a flow diagram as to how Gatekeeper works when you execute an application or a binary. Really, one of the first things that happens when you execute the application on a system is there will be an AV check. There's a built-in AV in macOS called Xprotect, and I'll just scan the binary. If it's malicious, typically it'd be denied from executing. Now, in my opinion, I don't think highly of Xprotect. In the 4 years that I've used the macOS system, I've never seen an Xprotect prompt of any kind. The second kind of check that occurs will be a quarantine flag check. Again, this is more of something that aids Gatekeeper into understanding whether something is potentially malicious or not. It won't completely prevent the execution, but often it might. And lastly, as I mentioned on the previous slide, there'll be a check for signing and notarization. If it has a signature and it's being compiled and created elsewhere, it will typically be allowed to run on your system. There are cases where you could still execute a binary without a sort of vetted Apple signature. The last kind of core security mechanism to talk about on macOS will be the TCC layer, which is essentially a user consent layer, they kind of take the shape as similar to these kind of pop-ups that you see on the slide, and they kind of give the user the ability to accept or deny particular actions performed by your application on your system. Typically, this would be when an application tries to access a directory such as your documents or your downloads, you would see something like this, or if it tries to access your microphone. So really the idea behind it is to give full control to the user so they can dictate what an application does, and they're aware at all times as to what this application does. It's important to note as well that this affects the root user too. The root user cannot circumvent these pop-ups in any way. So we've seen that macOS is kind of secure by design. The security pillars are kind of run deep and being weaved into the functionality and the design of the operating system. Generally, it's kind of the Apple way or the highway, and by that I mean Apple wants to tightly control the execution layer and kind of make sure they're involved in the distribution of software within their ecosystem. And lastly, Apple have kind of designed the user as the main entity and the most powerful entity on their MacBooks. So it's all kind of, they want to hand the power to the user to kind of protect their data and their privacy. So what does this mean for us as offensive security professionals or red teamers? What do we really have to think about when we try and run an engagement on a sort of macOS environment? So really one of the first things we have to consider and work around will be Gatekeeper, which handles the execution control. So we'll have to find a creative way of kind of executing something that kind of satisfies the Gatekeeper checks. We'll also want to consider whether or not we need to trigger TCC prompts. So there'll be cases where you can, depending on your execution, you can circumvent TCC prompts altogether. But perhaps as a red teamer, you'll want to spin up some very targeted ones that could blend in to the overall amount of prompts presented to the user. They might just click accept, as seen with like MFA for T tags. And lastly, you'll want to consider whether or not you want to do a privilege escalation to the root user, now knowing that the user is the most important entity on the macOS system.
Cool. All right, so I'm now going to take us through the part of the talk where we run through a sort of red team scenario, kind of the hands-on, how do we actually address the security controls that we've just run through if we're running a red team or a similar sort of offensive security engagement, or if we're hackers. First things first, we need to think about the types of things that we need to prepare on our side before we even think about touching our target's MacBooks. So first part of that is going to be Command and Control C2. I'm going to assume a certain level of familiarity with kind of red team and offensive security concepts like C2. We can chat afterwards if any of those kind of passed you by. So if you've ever done any sort of offensive security against Windows, you'll be familiar with C2 frameworks, so things like Cobalt Strike and Covenant and so on and so forth. And there's similarly for Mac lots of these out there, so you don't have to do all the work of creating Command and Control yourself. You can use someone else's work. Custom stuff is an option. It can be quite a good option, especially if you can just get AI to write it all for you. But whichever of these you choose, or whatever you decide to write yourself, there's kind of three main things that I would recommend you bear in mind. So the first one, I'll give you for free: avoid shelling out. Avoid shelling out. So by this I mean if you're familiar with Linux, there's tons of terminal commands on macOS that are going to be super familiar to you. However, actually using these is going to be one of the blue team's main signals that they can rely on to try and detect bad guys. So wherever possible, you want to try and do stuff in code. So that could be compiled code, scripting languages. Even if it's not super elite, you're immediately going to be head and shoulders above the competition that are using shell commands. Related to this, the second one, can anyone tell from the picture what I think your C2 framework should be? What is that table? It is extendable. You're not going to be able to predict every single line of code that you want to run on an engagement before you start. So you need some sort of way of delivering new scripts, dilib scripts, compile, whatever it is, after you've already got the implant, because otherwise you're going to end up having to go back to shelling out, doing the commands already there. And then the final one, socks. Yeah, so you'll want some sort of socks proxy or just some sort of way of tunneling traffic from your attacker machine through the victim machine out to whatever web services you're trying to hit from their context. Just one of the most common things that you end up needing in any sort of red teaming. Once you've picked or made a C2 framework with these sorts of things in mind, you then need to start thinking about how you're going to get that C2 framework running on your target macOS devices. And there's tons of ways you can run code on a macOS device, whether you're a legit software author or malware author. So a lot of these have kind of parallels with Windows methods of running code, some of them more direct than others. Importantly, anything from kind of install/container and up, you're going to need to get kind of signed and notarized, hence the steady growth of scripting languages, both native and custom, as a point of interest for malware. But before we pick our favorite of these and start writing malware, we need to actually think about what we can realistically get running on a device. It's all well and good writing some malware that works as an installer package, but if you don't have a way of getting an installer package to a macOS device and running it that bypasses all those security controls that we've run through, you'll have wasted your time. So before you start writing a payload, you need to find some sort of bypass to some of these controls. So the first one we're going to go in a little bit more depth into is quarantine. So I'm just going to go because I've got a little video thing. So I'm going to show you at a really high level how quarantine works. This isn't going to be like macOS internals. This is just going to be for like a slightly technical level. What does it actually do? So on the right hand side of the screen, we've got just a trivial web server hosting a file. On the left hand side of the screen, we've got a terminal in the user's downloads directory. So if we click to download it, and we list our downloads directory, well, hey, downloads work as you would expect on a macOS device. But the interesting thing is going to come here when we list the extended attributes of the file. So this is essentially metadata stored in, it's like the alternate data streams on a Windows device, if you're familiar with that. And what we're going to see, most importantly, is this com-apple quarantine attribute. This is Chrome essentially ratting on us and saying, you didn't make this machine, you didn't make this file macOS machine, I downloaded it for you. And then just for a simple comparison, if I just make a file with echo and then list its extended attributes with this exaptra command, we'll see there's none. So this quarantine thing is, it's like Mark the Web, it's something that gets applied when you download a file. And that's the screenshots in case they didn't work. So why do we care about quarantine? Well, as we mentioned earlier, it's what gets Gatekeeper interested in our file. So if we got a user to download that file and double click it and hadn't bothered to get it signed and notarized and had that quarantine attribute applied, then the user is not going to be able to double click open the file. Gatekeeper's going to look at it, say you've got quarantine but you haven't got a signature, so Apple's not looked at it, and say no, you can't run that. So what can we do about this? How can we avoid getting this quarantine attribute if it's so important for Gatekeeper? I'm going to show you kind of a trivial example that hopefully will get your mind whirring for like the general class of like how you can approach finding bypasses. So on screen, when it loads, is the me downloading the exact same file from the exact same web server, but instead of using a web browser, I'm using Curl. And even though this is like a really obvious other way to download a file, the quarantine attribute's not been applied. Why is this? Well, essentially, the quarantine attribute is not like a magical thing that macOS itself applies. Apple expects the people writing like software for a macOS to like apply that attribute themselves, right? But as you'll see, they're not actually all that strict about it when it's not a typical pointy click through your browser, download something type flow. And even something as obvious as curl just completely breezes through it. So if you want to try and get past quarantine, try and think of things that, from the perspective of the hacker, is a download, right? It gets the file on the disk, but might have snuck past Apple's enforcement of, please make your things apply quarantine on downloads. So if you've not managed to find a quarantine bypass and you're in a bit of a rut and you're just trying to get stuff to work, you might start Googling blog posts and find ones from even 2 years ago that say, well, just tell your user to right-click, run anyway. So
Right-click? Sorry, what's this?
you can set it to have a right-click, yeah. Maybe Command Control click, whatever it is. This is so this was really useful if you're super elite at social engineering, or maybe slightly more likely you're a red teamer doing an assumed breach scenario. But Apple have gotten rid of this in maybe about a year ago, and I think the way they did it is actually quite an interesting indication of how they approach some of these security questions. So what I'm going to show you, oh dear, there we go. What I'm going to show you is kind of what the equivalent flow looks like, what they've replaced right-click run anyway with, and just how hard it's going to be for you to get your target user to do this. So if you've got your user to download the file, they double-click it, they see they can't run it. What you then need to somehow convince them to do is go to the settings application, go to privacy and security, find the bit that says, we block this file to protect your Mac, click open anyway once, click open anyway twice, realise that they cut the video off too soon and click to the screenshot, and see that they now need to input an administrator username and password. I want to pause here for a second just to point out how kind of interesting this is. So that file, from like a traditional, I guess, Unix file permissions perspective, is just the user's file. They're perfectly capable from like that technical level of just removing the quarantine attribute themselves. That's not an administrator action. But what Apple have kind of done here to try and put roadblocks in front of attackers is require administrator credentials to do it in the kind of pointy, clicky, GUI way. And this is kind of, so this is kind of indicates like an interesting kind of dichotomy of that Apple is trying to balance here, which is to not block technical users from doing stuff themselves, like you could do this from the terminal easily, but try and put roadblocks in front of non-technical users getting fished into doing the same thing. So just another gatekeeper bypass method, and one that is actually going to work for you potentially, is using scripts. So Gatekeeper really at the moment is focused on auditing binaries. Scripts are text files, so Gatekeeper does not care. You don't need to get your script signed and notarized in order to run it. And so these are becoming like more and more interesting for macOS malware. So you've got things like native script interpreters like OsaScript. This one is possibly a bit overplayed by now. But you've also got things like Brew. So if you're not familiar, Brew is like the unofficial macOS version of like Linux package managers like apt or yum. It's unofficial, but if you're on a developer's Mac, but you're almost definitely going to find it. And then of course, IDE extensions. Essentially, in that, IDE extensions are basically JavaScript files run by an interpreter, which is your IDE. So again, it doesn't matter so much if they're not signed, notarized, free of quarantine. So one of the things I was kind of getting at with the gatekeeper bypass with the admin password is that in a lot of ways these security controls are just that little bit more lax when it comes to stuff that targets stuff that's going to be used by technical users, right? On the one hand, a MacBook is an expensive Chromebook, right? It's for business users to go on the web and use their important business things where their job lives. And on the other hand, they're really powerful developer machines, and like lots of developers really love them. So Apple has to kind of balance not getting in the way of developers too much. Obviously, they do a bit, but not getting in the way too much while protecting the sort of pointy-clicky business users. And this kind of dichotomy is one of the reasons why ClickFix has become such a prevalent attack vector, especially for Mac. So essentially, I'm sure you've heard of ClickFix by now, but essentially it funnels users who should never touch a terminal, who don't know what they're doing with a terminal, into suddenly using a terminal, into copy and pasting commands from your malicious website. Maybe you've hijacked search, poisoned search results with dodgy adverts, so on and so forth. You've gotten them into this zone where suddenly all of Apple's carefully crafted security controls are just that little bit more lax. So interestingly, this is getting more attention, and there are kind of up and coming security controls against this. I'm not going to go into sort of depth in them and how they work, but Patrick Raw's got a good blog post on it, since he got there first, and then Apple stole it, and of course has other ones as well. But there's various ways in which people are trying to like stop users from being so susceptible to this by throwing up warning messages and things like that. How well these things work, really, time will tell. So just to kind of wrap up that sort of payloads initial access section. If you want to deliver something that's essentially a binary, something that should be getting signed, but isn't, you want to try and bypass quarantine. And to do that, you want to try and find something that's a download, but not a download. If you can't find anything decent there, or you just really want to use script interpreters anyway, go for it. You don't need to sort of care about Gatekeeper at that point. You don't need to care about your files having quarantine or not. And in both of these scenarios, you're going to have a much easier time if you're able to funnel your users into terminal commands rather than GUI. But hey, go nuts. Try and find stuff from GUI applications as well. It's kind of more fun. Okay, so post-exploitation. What do we actually do when we land, when we do all this stuff and we land finally on a macOS device? So for the types of companies that we're really talking about in this talk, a macOS device is almost worthless in and of itself. It's interesting to us in terms of what it can give us, and typically that's whatever access our target user has to their company's cloud resources. So we're not even going to sort of think about getting root and bypassing SIP and stuff. We're going straight for the user's access to company resources. So, for example, if you've ever done red team or offensive security targeting like Windows or devices, or just any sort of device in a company that is sort of cloud heavy, uses lots of SaaS, you want to go straight for the cookies. And from the perspective of having an implant on a device, you're in a super good position to start going after these cookies. I am not going to go into lots of technical detail about the different methods. I recommend looking up a tool called Chainbreaker. That's my personal favourite. But just as a general gist of the concept, if your target's using a cross-platform browser like Chrome, well then your cookie theft methods are also going to be cross-platform, more or less. You'll have to tweak them a bit. There'll be some nuances, but the sort of core concepts are the same. So you have things like remote debugging, stealing from disk and then figuring out how the OS does the crypto. A lot of that stuff is going to be kind of analogous. If you are lucky enough to land on the MacBook of a developer, then you can start trying to find things like CLI credentials. So if they've used AWS CLI, or maybe if they have code on their disk that you can try and like backdoor, so hop into CI/CD that way. Things that you might find when trying to sort of root around in the user's home directory. As a word of warning though, be careful of TCC. So as we sort of brought up earlier, TCC demands that you get user consent if you try and access desktop documents, downloads, and some other email as well. Yeah. This is really going to hit you if you accidentally do like a recursive file listing. So you think you're just hitting home directory, but your C2 is actually going into all of the subdirectories. You're suddenly spamming loads of prompts without meaning to. If you manage to land in a process that has TCC permissions, great. Do what you want, access files you want, go for it. But if you don't have the TCC permissions you want, then really there's two approaches you can take. One is to spam prompts. This really will depend on what process you're in and how gullible you think your user is. So if you're Google Chrome trying to access downloads, you're probably going to get away with it. They'll probably click OK. But if you're something really dodgy, then maybe you won't. But if you don't have that and you don't have that kind of confidence, then really I'd suggest just stick to the home directory. If you're on a technical user's laptop, there's going to be dot files and these sort of like dot directories with like interesting cloud stuff in there that you can have a lot of fun with without ever trying to sort of mess with TCC. So once you've done that, once you've figured out a way to access the user's cloud resources and things that are important to them for their job, really we've now stepped out of the realm of macOS red teaming, and we're really just in the realm of standard red teaming. This is the point where you now just need to think about what's important to the company that you're targeting and like how you can kind of impact that. So if they're, I don't know, a company that sells, I'm looking at projectors. If they're a company that sells projectors, how can you disrupt their projector supply chain or maliciously send 1,000 projectors to the wrong unit or whatever it is? At that point, macOS is kind of irrelevant. And that is that for my little section.
Thanks, Matt. So a few defense and OPSEC considerations. Nice. We've looked at a few of the core security mechanisms on macOS, but what would you do if you wanted to take things further and better protect yourself? There's the Objective-C Foundation, ran by Patrick Wardle and his team. They've released a bunch of open source tools such as Lulu, Knock Knock, and Block Block, and other tools with similar weird names. And generally the idea is to give the user more control of their system, either by providing more consent boxes for, downloads performed by random applications and scripts, or perhaps tools that allow you to identify library hijacking vulnerabilities on your system, etc. And if you're an enterprise or corporate environment, you might consider something like Santa, which is almost like a more granular way of controlling your application control, or doing the application control side of things. This was started by Google and I believe is now maintained by NorthSec Security. But not bad as an option for application control. Next we have ESF, the Endpoint Security Framework. So ESF is basically like a bridge between the userland side of macOS and the kernel, and it kind of provides telemetry from the kernel into the userland, more specifically to applications and binaries that have a specific entitlement. So this kind of system might be leveraged by security vendors such as AVs and EDRs to kind of ingest this telemetry. So a bit of history. In the past, macOS actually allowed you to load in kernel drivers or kexts, but this was kind of prevented when, I think with SIP, and generally to kind of prevent tampering with core OS functionality, sort of opted for this ESF bridge. So the kind of telemetry that this will give you will be things like process execution, fork and exit events, perhaps file creations and write events, and other things such as process memory mapping, etc. So if we take a sample malicious Python script, something that kind of downloads a binary, writes it to a disk, makes it executable, and then runs it as a child process, what kind of telemetry would that give us with ESF? So in this case, we've opted for Red Canary Mac Monitor, which is one of these open source ESF telemetry ingestors. There's a whole variety of them that you can find on GitHub. And we've kind of traced the activity to kind of show it to you. So you'll notice when we execute the Python script, we'll have a notify execute event, and this will kind of indicate the Python command line that we used. And you'll also notice the code signing details. In this case, you'll notice that there's the Apple signature there because Python is a vetted and approved application for macOS systems. We'll see that for the file creation, write, and chmodding events, we have, again, equal granular kind of telemetry for each one of these things. And something to note here is that the quarantine flag is marked as not having been applied on the downloaded file. So this kind of ties into what Matt was saying earlier, how kind of applications have the responsibility of applying this flag. And in this case, things like script interpreters such as Python do not apply this flag. So this could be useful for your future engagements. Last, we execute our binary that we downloaded with Python. In this case, it was I think something like a C2 agent, but you'll see that it's flagged in orange, as in the exec event is kind of suspicious, and this is most likely due to the fact that the code signing is like the signing element is a bit odd. You'll notice an ad hoc signature, which is almost something like a debug signature or a temporary signature that allows for a file to run under certain circumstances. If you're curious, this is a Lulu alert. If you had Lulu running on your system, which kind of detected the binary download in Python and provided an extra layer of consent to the user. So if you're kind of interested in the whole ESF telemetry side of things, whether you're an offensive security professional trying to make yourself more stealthy, or perhaps a defender trying to identify gaps, you could use something like the EDR telemetry web resource. And this will document what a lot of the top vendors kind of use and what's not being used, and you can work with this information. So what have we learned from this talk? Generally, Apple invests heavily in kind of preventing the execution, or rather unintended execution, and they apply a lot of control there. If you're kind of new to macOS, once you understand some of the core functionality and like understand the system, you can kind of get creative as to how you're going to target it and work with the kind of environments they're associated with. You can use ESF to your advantage as an offender to kind of understand your footprint and the IOCs you kind of create. And you should definitely be testing your attacks and such in labs and seeing if they trigger TCC events, as mentioned by Matt, when you're crawling systems, etc. And other than that, we kind of wish you happy hacking